In this video, we're going to be looking at how to interpret the questions that are being asked using function notation. So we're going to decide, well, what are they actually asking you to evaluate here? In our first problem, it says evaluate f of x equals 3x plus 1 if x equals 3. So right here, we know x is our input value. So they're asking us to input 3 wherever x is and solve. So we mainly just need to plug it into the equation here. So to solve it, we have 3, and instead of x, I'm inputting the other 3, bringing down the plus 1. So again, we just replaced x with 3, and if we solve 3 times 3 plus 1, we know the answer is 10. So what we see here is if we have f, and again, I can input the 3 here, f of 3 is equal to 10. So again, we're just replacing x with the value of 3. We could do the same thing if I was asking for you to solve for, if x was, let's say 30. So again, I'm just going to plug it into our original equation. 3x plus 1 is now going to become 3 times 30 plus 1. So when we solve, 3 times 30 is 90 plus 1, we get 91. So again, now we're solving for f of 30. I'm just replacing the variable x with 30, and the solution is 91. So now it's your turn. I want you to evaluate if g of x is 3x minus 5. What if x was equal to 4? So pause the video and go ahead and solve. Alright, so if you follow my work here, when we plug in x is 4, we get g of 4 equals 3 times 4 minus 5. That's 12 minus 5, and we get 7. So for evaluating when x is 4, g of 4 is 7. Did you get it? In this next problem, you'll notice that they kind of switch it around on you. This time, if you're given g of k equals negative k minus 4, if g of k equals 8, so now they're giving you the g of k, which is the output, is 8. What is the value of k? So remember, k is our variable, k is the input, so now we're trying to work backwards to find what the value of k is. So as you can see here, what I did was I took our output value, g of k is 8, and I substituted it in for g of k here before the equal sign, and then I just brought down the rest of our equation. So now I need to solve for k. The first thing we need to do is inverse operations. Instead of subtracting 4, we'll need to add 4 to both sides. To cancel these out, we get 12 equals, we do need to make sure we bring down that minus sign or that negative sign. So we have a negative k equals 12, but I want to solve for k, not negative k. So this is like saying negative 1 times k. So in order to get rid of it, we will divide by negative 1. Got to do the same on both sides. Whatever you do to one side, you do to the other. And so these will cancel out. Negative 1 divided by a negative 1 is just 1. So we don't write 1, we just write k by itself. And our answer will be negative 12. So we come up with k equals negative 12. Or we can write g of negative 12 equals 8. All right, time for some practice. So for our first problem, we're going to use h of x equals 5x plus 1 to solve the following. So I want you to solve for these input values, h of 5, h of 10, and h of 12. Go ahead and pause and try and solve these problems real quick. Okay, so showing my work here, I took the 5x plus 1, and instead of x, I plugged in our input values and solved to get h of 5 is 26, h of 10 is 51, and h of 12 is 61. In this second set of problems, you'll notice we're using the same equation, h of x equals 5x plus 1, but now we're going to solve these, and notice this time I did not give you the inputs, I gave you the outputs, so we're having to solve for x in each one of these situations. So again, pause the video and try and work backwards to find the input. What is the value of x? Alright, so here is the work to, or well, not the work, but the answers for you to check and see if you got it right. So if we plug in 6 into the equation, 5 times 6 plus 1 is 31. If we plug in 8, 5 times 8 plus 1 is 41. And our last input of 20, 5 times 20 plus 1 is 101. So these are our answers for our input values 6, 8, and 20.